Did you ever wonder why the doctors are prescribing the medicines for the different durations of the time? Sometimes you must have to consume only twice, while in some cases you must have to consume it thrice. Sometimes the doctor is prescribing the medicines for once in a week. What could be the logic behind all these? You may be thinking that you are the mathematics student and it's not your headache, but you are wrong. It's the subject matter of mathematics. There are some rules for the medicines to be effective. The first one is it should not be too much. If you will intake too much medicine, then it will cause harm. And it should also not be too less, because if it is too less, it will not be effective. So there must be a required quantity of the medicines which should be taken. As per that, the doctor is prescribing sometimes full medicine, full tablet, and sometimes he is prescribing half. Next, if you have to take the medicines after every 6 hours, it means that the effect of that particular drug will remain in your body only for the 6 hours. After that, its effect will vanish and you have to consume it again. He must also concern about other factors like when you consume the medicines, your blood will increase, your blood pressure will increase, and after some time it will again falls down. So from he must have to know that what quantity of drugs must be given, because if it is too much high, then blood pressure will rise too much, it is harmful. But now the question is that how can we calculate these things? Because in geometry we just studied about shapes, how to measure the volume and surface area of these shapes. In algebra we just calculated the equations. In simply we can say that how to find the value of the unknown variables. But now it's look a little bit complicated. How can we determine the amount of medicines which we must have to intake? Is there any mathematical methods? So let's have a look. For that we have a new branch of mathematics, that is calculus. What is calculus? Calculus is a branch of mathematics that studies change. It's not static, it's dynamic because it studies change. While algebra deals with numbers and solving equations, geometry deals with shapes and space. Calculus deals with the things that change continuously, like speed, growth, motion, population, money, etc. You can say that calculus is the mathematics of motion and change. If you want to know how fast something is moving at an instant, you use differentiations. And if you want to know the total distance covered from all those tiny motions, then you will use integration. Let's understand it with the help of an example. You all may have traveled by a car. A car speedometer shows us instant speed. That means the speed of the car at that particular time. And that is calculated by the differentiation. The odometer, which measures the distance traveled by the car, it uses the integration. For simplicity, I am giving you one more example. Think of water filling a tank. The rate at which the water flows in liters per second is differentiation. The total amount of water collected after 1 hour is integration. Now you all may be thinking that what is differentiation and what is integration? Differentiation, which is also known as derivatives, tells us how fast something is changing at a given moment. Example, your car speed at 10:05 am. It's telling about change. how fast a change take place. That is differentiation. But in the case of integration, it tells us the result in total, and that is the total distance your car traveled at a particular time, that is from 10 to 10 am 10 am. Now let's move back to our example of medicines. Now we know that differentiation refers to the rate of change. Imagine if you take a pill, the drug level in your blood starts rising. Differentiation answers how fast is the drug level changing right now. In the starting, when you consume the medicine, your drug level starts to rise. So, in the first hour, when you consume the medicine and it starts to spread in your body, at that time, your drug level may be rising 5 milligram per hour. At 4 hours, the drug may be falling, that is 3 milligram per hour. Means that after 4 hours, your drug level again start to fall. The derivative tells us the speed of change. How fast can the drug level fall? So when you know the speed of change, then you can prescribe a time to take the medicine again. If its rate of change is very slow, then you can prescribe it after 12 hours. But you know its rate of change, its speed of falling is very fast, so you are prescribing the medicines after every 6 hours. Now we know that when we consume the drugs, our drug level starts to rise, and after reaching a particular limit, it again starts to fall, and it continuously falls over time. Now suppose the drug level is going up and down through the day. Integration answers what is the total amount of drug that stayed in the blood over 24 hours. Example, even if the drug level changes every minute, integration add up all those tiny amounts. Means in 1 minute how much drug is losing from the body and how much stays there. The integration add up all these tiny amounts. This gives overall exposure of the body to the medicine. From this we can conclude that how much effect of a medicine can be on the body, because now we can calculate how much drug is there in the body. The simple difference between the integration and differentiation is that differentiation is zoom in. It means what is happening right now. And integration is zoom out. What's the total effect over the time? Differentiation is considering the small units like 1 minute or seconds, and it is considering what is the change at that time. We can say that in 1 hour how much drug level falls from the body, and what is the falling level of the drug in the body over the period of 1 minute. Then we can move on to 1 second. So the differentiation is telling us about the rate of change over time. A particular time is given, we have to find the rate of change. But in the case of integration, what's the total effect over the time after this rising and falling of the drug? What is the total effect of the body over the time? That we can calculate from integration. You can relate both integration and differentiation with this curve. The area under the curve shows that total area under curve, and the totality is shown by integration, isn't it? The totality is shown by integration. So if we calculate the entire area under this curve, then we will get the integration. The differentiation is change in this slope. because differentiation is related to the change. So from here we can calculate the change in the slope of this curve. So it is known as, if we calculate the slope of this curve, then we will calculate differentiation. If we calculate area under this curve, then at that time we have to find the integration. Now, why the calculus is important? Without calculus, we can't predict the planet's motion, means the motion of Earth, motion of Mars, etc. Calculus also helps in the formation of bridges and skyscrapers. It determines the curve. What should be the curve? Because we can't determine a random curve for any bridge. It will not be stable. If we want to make a stable and strengthful bridge, these curves should be based on a proper criteria. So they use the differentiation to determine the slope of this curve, and they make calculation of the weight of different objects, and after that they decide that what should be the strength of this bridge. That is with the help of integration. They are integrating the weight of different objects, and as per that they are constructing the bridges. In the case of skyscrapers, when there is earthquake or strong winds, at that time these scrapers starts to sway. As per calculus, we use differentiation to determine that how much degree of swaying is allowed, means what amount of swaying is not harmful for a particular scrapers. And with the help of integration, we determine that what should be the strength of these particular scrapers, because inside that there is the weight of different objects, humans, and other requirements which human needs in their daily life, like furnitures, fridges, etc. So there are multiple objects in a single skyscrapers. They determine the weight of all these objects as per integration. Calculus also helps them to use few materials and construct a strong structure, because we can't waste steel, iron, and other objects which helps to create the skyscrapers and bridges uselessly. Calculus helps to take better decisions how much amount of material is required for the creation of particular structure. Moreover, calculus helps us to understand the population growth, design medicines, calculate profit changes in economics. So far we have discussed about the integration and differentiation. Now we are going to start the infinite series. What is an infinite series? A series which is adding forever. Sometimes problems need us add up infinitely many terms. Example, 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16, and so on. At last we will get the answer 1. It means that this series, if we add this series, it is approaching 1. What is the logic behind this? One thing you can know, 1 by 2 is our first step, and 1 by 4 is the half of 1 by 2, 1 by 8 is the half of 1 by 4, 1 by 16 is the half of 1 by 8. But there is a simple way to remember. Here 2 power 1, next is 2 power 2, next is 2 power 3, and so on. This is the logic behind this series. We are adding it up to infinity to get the 1. Infinite series helps us to approximate the complicated functions and solve real-world examples and problems like physics, economics, and finance, etc. Like in the case of integration, we had studied that integration is adding up all things and consider the total. But what is the difference between infinite series, as it is also adding forever? The basic and foremost difference between the infinite series and the integration is that infinite series consider discrete data, which can be calculated one by one. On the other hand, integration consider a continuous data. The area under a curve is a continuous data. But if we consider 1 by 2 plus 1 by 4 plus 1 by 8, all are different objects. So we can say that infinite series consider the discrete data while integration consider the continuous data. Now we can say that calculus is equals to differentiation, that is instant change, plus integration, that is total change, plus infinite series, that is smart infinite addition. In this we add 1 by 1, which is discrete in nature. Now the question arises that why calculus works. Calculus works because it uses the power of limits. What? Limits. Limit is the basic stone of calculus. What is a limit? A limit means what happens as we get closer and closer to something. Let's understand this with the help of an example. Walking towards a wall which is 10 steps away. A person who starts to walk towards a wall which is 10 steps away from him. He moves 2 steps, but he did not reach towards the wall. He came here. After that, he moves 3 steps more. Now, already he has covered 2 steps. If he moved 3 steps more, then he will reach at 5th step, but still he did not approach to the 10th step. Again he moved 3 steps more, then he is even closer to the wall, but still he did not reach to the wall. Now he is at 7th step and 3 steps away from the wall. You never step on the wall, but you get closer and closer. It means that we will never step on the wall, upon the wall, but we are going closer and closer. This limit is that wall is a particular limit. We can't cross the limit, but we are approaching it. We are leading towards it. This particular concept is known as limit. Suppose you want total distance. You break the trip into steps and add them. You want the total distance towards the wall and you break it into steps, plus you take one step and calculate 1, then other step calculate 2, 3 and so on. It means that you are calculating the steps towards the wall. If you add infinitely many tiny steps, you get the exact total distance. The endless ending equals to limit. Understood? We break the particular distance into few steps, like you came here 1, 2, 3, 4, 5, 6. So we are calculating with the help of steps. Steps by steps we are moving on and we are calculating that how much the distance from that person to the wall. So at last you can calculate that it is 10 steps or 12 steps. So that endless ending is known as limit. Calculus works because we use limits, shrinking things super small or adding super many. Its most important line of this chapter, shrinking things super small or adding super many. I want to tell you that we are shrinking things in super small in differentiation and adding super many in integration. Let's understand it with the help of an example. Imagine you are watching a car on the road. 2 questions come to your mind. How fast is it going right now? Then this will be known as differentiation. And the next question will be how far did it travel in total? What distance it might be covered? This is the matter of integration. But the matter of concern is that how do we answer these? We use the idea of limit. For speed, we consider differentiation. First, you measure the speed over an hour, not exact. Then over minute, it's better than that. but then you calculate over seconds. It is very close to the actual result. While you are calculating by using 1 hour, you may get a result, but it's not that much accurate. Instead, you take 1 minute. Your result will better but not accurate as compared to the seconds. Then you consider the seconds. Now your result is very close to the actual result. If you keep shrinking the time gaps smaller and smaller, you get the exact speed at that instant. That shrinking process equals to limit. That was what we considered about the differentiation. Now consider the integration. We use it to answer the distance. How much distance will the car cover? Suppose you want the total distance, you break the trip into tiny steps. Add them step plus step plus step. Like we calculate the step of that particular individual towards the wall. In the same way, we will calculate the steps of car. You can calculate like 1 kilometer, 2 kilometer, 3 kilometers. If you add infinitely many tiny steps, you get the exact total distance. That endless ending equals to limit. I hope you may get what this want to say. Calculus works because we use the limits, shrinking things super small that we does in the case of differentiation, or adding super many, that we add small steps and we get the entire distance, and in the case of differentiation we break. First we consider 1 hour, then we take the smaller unit, that is minute, and then the super small, that is second. This shrinking things to super small is the concept of limit, and adding super many is also the concept of limit. But this one you have to do in differentiation, while adding super many you have to do in the case of integration. A limit is a number you approach even if you don't exactly reach it. Even if you don't get the exact distance or exact speed, still you will approaching that particular number. For example, your distance is 20 kilometer. While you are calculating 1 plus 2 plus 3 plus 4 plus 5 plus 5.5 etc., you may not get exact 20, you may get 19.5 or 20.1. You can get these answer too, but the matter is that you are approaching, you are going towards the distance, that is 20. Same in the case of speed also. If it is 10 kilometer per hour, you may not approach the exact speed, but still you are approaching it, like 9.1, 9.55, 9.99. You are approaching it. So a limit is the number you approach even you don't exactly reach it. Next is continuity. What is continuity? A function is continuous if its graph can be drawn without lifting your pen from the paper. For example, you are drawing one graph, you are drawing like this, so there is no need to lift the pen. But if you are drawing one graph which is like this, then next is like this, so you have a need to lift your pen because you can't draw it without lifting the pen. So in the simple words, as per layman language, we can say that the drawing or the graph which we can draw without lifting our pen, that is known as a continuous function. Example, a straight road. A smooth road equals to continuous. There is no break, but a broken road, you may have seen there are holes. So holes and jump, speed breakers. In the road there are speed breakers. So that case, this is not the continuous. It breaks our flow of speed. A sudden hole or jump is not equals to continuous. Example second is temperature of tea cooling. Temperature goes down smoothly with time, no sudden jump or hot. At first our tea is too much hot and then it does not freeze. It will first become a little cold, then it will become more cold, and at last it will become completely cold. So it is not a discrete process, it is a continuous process. So continuous equals to no break, no jumps, smooth curve. Like this is a smooth curve. These concepts are for your introductory class. I hope you got it. In the next class, we will start it properly with formulas and derivation. Thank you.